Okay, right, let's see.
So the glasses is not good.
How's this transfer doing, by the way?
Glass not good. Don't ask me.
Come on, be good. I think this is finished. That looks like it's not there. Whoa!
Sorry.
Careful now. Right, circular motion.
Give me one pen. Do you have?
I already have the one. So. Let me check. Yeah. I think, yeah.
Okay, you got that?
Yeah.
Yeah, circular motion. Yeah, okay. So, we have quite a bit to do. Okay, sorry. Oops. So, yeah, actually, a good bit to do. Right, first things first. Some terms here for the circle, which will be helpful. I think we all know what the or is called. Radius. The theta, angle, and the S. Sector is actually the kind of the whole piece of this. I just want what's coloured here. No.
Maybe I need a better circulation.
I'm just concerned about the S right now. Does anyone know its name? Nobody? Nobody? No.
What's your question?
What's the S called? I'm getting desperate now. Arc length. Arc. A or C. So, theta is the angle, or is the radian, and S is the arc length. I thought someone would know that. Did you?
Yeah.
Really?
Yeah.
Okay. What's that about Rahman? Is he bad mouthing you, Rahman? What's he saying?
No.
Oh, okay.
Tashwish.
Have you got this?
No.
No? Okay.
This song is beautiful.
Okay, you got this? Yep. Next now.
No, I don't have it.
Ah, come on now. There's not a lot here to write down, Bello. Come on.
Quickly.
Yes, quickly. Right. Now, next. Yes? So in physics, when we are looking with motion in a circle, we don't actually use degrees to measure the angle. We use a different unit called the radian. Now, the definition of the radian is, now before you write this down, I just need to explain it. It's the angle which gives an arc length of or in the circle of radius or. Mathematically, 1 radian is about 57.3 degrees. Now, I'll just draw what that means precisely. Oh, come on back. Don't go. There we go. Right, so if you have a circle and you have here radius or, and here you have radius or, and you choose the angle so that you can make the arc length here radius or as well.
Yeah.
Then what you say is here you have 1 radian, which is roughly, I tell you there, whoops, sorry, roughly 57 degrees. Okay. Now, the reason why radians are important will be explained in maths class later when we look at it. In fact, the 57.3, if you want to be more precise, the 57.3 is actually 180 over pi, to be more precise. For physics, it's important because the formulas we will use will only work if we're using radians. So very shortly I'm going to give you formulas, but they will only work if the angle is in radians. Okay. Now, I don't think you need to write down the last paragraph, but you certainly need to write down this. This is a definition I've seen them ask this in the exam. Okay, nearly got that?
No.
Question?
Wait a second. Fast.
Yeah.
Huh?
Huh?
Slow.
Like
Stop it.
radius,
Yeah, that was on purpose, because that's the definition. Okay. We got that?
Yeah.
Right.
Just that.
Did you see the picture I drew? Okay, so you can see I was deliberate in it. I wanted the R. Right. Let me give you a small question using your calculator. I think you can handle this. I want you to convert 0.25 radians into degrees and 30 degrees into radians. And what can help you is remembering that 1 radian is 57.3 degrees. Okay, have you got that?
No, wait a second.
Okay. Right, what's the first one?
In the motor.
14
plus rate.
Yeah, 14.3. And the second one, 30 degrees?
No?
Now, 30 degrees should be less than 1 radian, son. Yeah, it's about half a radian. Yeah, good, okay.
What?
You must... Son, 57 degrees
Yeah.
is 1 radian.
Then x radian is equals to 0.
So 30 degrees must be less than 1 radian.
You put
Yeah.
this here. This is not in. This is what you
Continue.
for now, what you have.
Right, so we've seen 2 types of motion so far. The SUV-AT motion in 1 dimension and SUV-AT motion in 2 dimension. Now we'll look at a new type of motion in 2 dimensions, motion in a circle. Firstly, what makes motion in a circle? So if you have something that's moving in a circle, what's the cause of that? What type of force? So before you write this down, if an object is moving in a circle, then the reason is there's a force acting on it. Okay, well that's fine. But the force acts on it in a very special way. it's perpendicular to the velocity and directed towards the center of the circle. So, if you see something moving in a circle, here it is here, and you see it's moving around in a circle, it is because there's a force which acts perpendicular to the velocity, so that means this direction, and this force always points to the center of the circle. When you have that situation, you can have motion in a circle. The force is perpendicular to the velocity and towards the center of the circle. That's what's happening here. Okay? I think I would need you to write this down carefully, and I've already drawn it, so write that down carefully. Okay, if you got that? Yeah?
Wait there.
Okay. We got that? I think we should continue. So, the name, yeah?
The drawing.
You need the drawing? Yeah. Okay. Now, the name of this force actually has a special name. Does anyone else? Yeah. This is called the centripetal force, and it's the force that acts on any body that revolves around a center. This force contributes to keeping the body in circular motion. Now, you don't need to write that down, but you definitely need to write down the name, centripetal force. So this force here is called the centripetal force. That's the name of it. Okay. Now, remember F equals ma. In fact, if m equals 1 kilogram, we would have quite simply F equals a. Basically, what I'm trying to say is it shouldn't surprise you that if there's an F here, then there's also an acceleration here. Because remember we said F equals ma. And in fact, if m was 1 kilogram, then F would equal a. So not only do we have a centripetal force towards the center, we also have a centripetal acceleration. So the acceleration is also directed towards the center. Again, you don't need to write this down, but you should write the name down. Centripetal acceleration. So if F equals ma, if this is called centripetal force, then this is called centripetal acceleration. Yeah? So if you can write the name down just, centripetal acceleration. Okay? Yeah? Continue? Yeah? Okay. So, we have some definitions now. The first one is called angular velocity, omega. And it's the rate of change of the angle with respect to time. And the unit would be radians per second. So before you write it down, I'll just give you an example. So imagine we have something moving in a circle. It starts here. And then maybe it moves 2 radians in 1 second. Okay? We would say its omega is 2 radians per second. Basically, how quickly the angle changes. Okay? So if you can write that down, that's the angular velocity. Okay, have you got that? Yeah? Continue? Right. I've talked about an example already. Now, the next definition you need is called the periodic time. What do you think this represents? Time to take to do what? To complete one rotation, revolution. The periodic time t is the time taken for one orbit to be completed. And what would be the units?
Seconds.
Of course, the units are seconds. Okay.
One orbit has a 360 degrees or one.
Say again?
One orbit, you mean like 360?
Not 360. We use radians. Actually, I should have said that. Oh, well, maybe you know it already. How many radians in a circle? Nice try, but you forgot 2 of them. 6.28 radians in a circle. Okay. Two eight. Okay, have you got that? Have you got that? Yeah? Yep. Next now. We have this unit called per second. It's often called a hertz. In other words, 1 hertz is also called 1 per second. And the reason we use that that unit is for something called frequency. And frequency is how many orbits you can do in a second. The unit is the per second, of course, the hertz. So, if the frequency is 2 hertz, then in 1 second, how many orbits are done? 2 in 1 second. Okay. What if the frequency was 0.5? A half orbit is done in a second. Okay, so write these definitions down. Okay, have you got that? Continue? Yes? Okay, so now we have some formulas for circular motion. Okay? The first one is time equals 1 over f. Okay? Second one,
Time and period.
yeah, periodic time, yeah. Omega is equal to 2 pi over t. It's equation 2. Equation 3, V equals omega or. Equation 4, A equals B squared over or. And that's it, those 4 equations. Now we'll have a look at some examples now. So make sure you write these down carefully. Okay, have you got those? Have you all got those examples? Sorry, those formulas. Let's have a look at some examples now. So the first one is a CD spins at 500 RPM. What's RPM? Revolutions per minute. So in 60 seconds, how many cycles? 500. So this is a short question. I want you to figure out what the omega is, and then I'll do it in a minute. Okay, have you got that? Have you got that?
Yeah.
Yeah? Let's have a look. So, you have 500 RPM. So that means your frequency, if you want to think about it like this, is 500 per minute. So that means that's 500 per 60 seconds. So that means that's 500 over 60 per second. Now, what is that 500 over 60? I'll just write that as 25 over 3, isn't it?
Yeah.
Per second. I don't want the frequency. I wanted the omega. What does the omega equal? 2 pi over t. What does t equal? 1 over f. So this is equal to 2 pi f. So that would be whatever 50 pi over 3 is. What's that, please? Oh no, that doesn't sound right.
The y is
Right.
180.
Of course it's not. Of course it's not. You know what the pi is. It's 3.14159265.
But in the circular, you use that right.
Pi is pi. Pi doesn't change. Pi is pi. Pi is 3.14. 52 points. That sounds right. 52.4 radians per second. Okay. You have that? Yeah? Okay. Next one. A car takes 5 seconds to drive around a roundabout of radius 6. So let me draw that here. You have a car, it drives around in a circle, and the time is 5 seconds. And the radius is 6 meters. And my question is, what's the V? Now again, I'll give you a minute, see if you can look at the formulas and figure out which one you need to use. So I want to know what is the V. Got an answer? What did you get? Good, yeah. So what formula? Well, it's omega or. Now I do know the or, but I don't know the omega. So the omega is 2 pi over t times c. Great, so I know the v, the t, and the 2 pi. So this, the v, what did we say the v was? Oh, sorry. That's terrible. My v, okay, or. Right, or is 6, so that's 12 pi over 5, isn't it? Yeah, and this comes out to be 7.54 meters per second. So the car is travelling at a speed of 7.5 meters per second. Is that okay? Yeah? Next now. Let's have a look at the next one now. A boy swings 1 kilogram object around in a vertical circle of radius 2 meters at a rate of 2 hertz. So here we have, I'll draw you the picture. So he's spinning it around in a vertical circle here. And we have mass of 1 kilogram, radius of 2 meters, and a frequency of 2 hertz. And I think you'll find this easy again. I want the V. Okay, you got that? Yeah? I think it's very similar, isn't it?
Yeah.
V equals omega or, which is 2 pi over t or, which is 2 pi over 1 over f or, which is 2 pi f or. So what do we get here? 2 times pi times 2 times 2, 4, 8 pi, what's that, about 25?
Yeah.
Yeah. Okay. Now, next. Now, actually, before I do that one, there's another one I want to do. Actually, I just want a second part to this one here. So you can use the same numbers. If I just look at what's happening here, here, and then I'll draw one up here. I don't care about when it's here or here. When you look at the top, what forces are acting on the mass at the top? Gravity and gravity, yeah. Tension in the string. So there's two forces here, isn't there? There's a weight plus a tension. Okay. Now, when you look here, again, there's two forces, but there's something different happening here. Yeah, what's going to happen here is it'll be tension, but the weight goes the opposite direction. Now, will those tensions be the same? In fact, they won't. They won't. Okay. What's the same here? Are the weights the same?
Yes.
Yes. The force is the same because it's the F that makes it move in a circle. But these T's are different. Okay? Now, if you picture this, which T will be bigger? The one at the top or the one at the bottom? Bottom. The tension at the bottom is bigger. And you know this because when you swing something around in a circle, when is it most likely to fall? When it's at the top is the most likely when it'll drop. This is because the string is least tense up the top. Okay? But when it reaches the bottom, it's quite tense. So what I'll do, this one is a small one, so I'll call that T1. And this one here is bigger, I'll call that T2. T1 is smaller than T2. What I want you to do now for me is calculate T1 and T2. Now I've seen this in the exam before, so I want T1 and T2. Now my tip, my advice is first get W and F, and then you're finished once you have W and F. W is easy, so really you need to try and find F. And F is easy enough to find. Don't forget you can use F equals MA. Okay, have you got that?
Yeah.
No? Got that? Yeah? Both T1 and T2? So let's have a look here. I'm going to start by getting W. Hello. W equals mg. And what did I say the m was? 1. So what's the W? 9.81 newtons. Okay. F, let's get the F now. F equals ma, which equals 1a, which equals a. And we said a is v squared over r. Do we know v squared? What was it? 25.1 squared over 2. Okay, so what's the F here? Was it?
350.
350?
No.
15.
315 newtons. Okay, so if I use this now, I can say T1 equals F minus W
304.19.
and T2 will be 315 plus 9.81 newtons, which is
323.8.
323.8. Yeah? There you go. And there's the two forces here, the two tensions. Yeah?
T1 is F plus max.
Hmm. Do I have them the wrong way around?
Yes.
T1 is F minus W. If I take the W over. Okay, do you have that? Yes, can I continue?
Yeah.
Okay. So this next one here, a 10,000 kilogram plane is banking. So that means the plane is at an angle as it turns in a circle. It takes 1 minute to circle a path of 1 kilometer. What is the centripetal force? So I'll just draw that for you. If you were to look at it like this, you have your plane. That's it there. This is me looking at it from above. Okay, and it's traveling in a 1 kilometer circle. Now, if I look at it front on, so here's the plane. There's the pilot. Okay, there's the wings. So what's happening is it's moving around in a circle. Okay, and let's see. We know its mass. Its mass is 10,000 kilograms, and we know the time here is 1 minute to travel in a circle. There are two forces acting on this plane. What are they? You have a weight, obviously, and what else? What else? Well, there's something called a lift force to keep the plane up in the air. Okay? Now, this is all the information, isn't it? Yeah. My question is, what is the angle here? This theta here. I want this angle. Now, this is getting a little tricky. I'll give you a minute to try it. See if you can get it. And I have seen this one in the exam too. And in fact, it might help you to know, if you look at this picture, in this picture here, there's a force F to the left, to the center, of course. It might be helpful if the first thing you do is to get this F. How are we doing? We got an answer?
Nothing.
Maybe.
Maybe. Oh, good. Okay. Will we have a look? Or do you need a minute? Well, I hope you got the F okay here, yeah? So F is MA,
Yeah.
yeah? Which is 10,000 A, yeah? Which is 10,000 V squared over R. Let's zoom out a bit more now. Which is 10,000, and the radius is 1,000. And the V we don't know, but we can say it's omega R, can't we? Yeah. Okay, so that's equal to 10, and omega is 2 pi over t, and then there's the R squared. Right? So let me see, that is 10 times 4 pi R squared over t squared. So that's 40 pi 1000 squared over 60 squared. Okay.
Pi squared.
Oh, thank you. So what do I get here for the F? 1 1 0 0 0 0. Enough zeros. Okay. 11,000 newtons. Yes, do we agree? Agree or disagree? Is that right or wrong?
It's a bit different. 10,900.
Okay, you got 10,900. So so maybe like this?
Yeah, it's 100,000.
So if you do three significant figures, it'd be 11,000. Although for calculations, we should do four significant figures. So what's four significant figures?
Oh, yeah. It's 11.
It's still 11.
Yeah.
11,000 newtons. Yeah? Okay, now, the next part. If you look at this...
I think it's one more zero.
Oh, sorry. One more zero, thank you. Now, if you look at this picture here, okay, let's resolve the L. So this one here is L cos theta. This one here is is W. And then this one here is L sine theta. Now, let's see what we know. Do we know the W? Of course we do. Yeah. Do we know L sine theta?
No.
We do. It's 110,000. Because this is the force that is making it travel in a circle. So this here would actually be this. And do we know L cos theta? We do. What should it? Yeah. Why? Yeah. Well, the plane isn't rising or falling, is it? It's constant. So now we can make this equation. We can say L sine theta equals 110, and we can also say L cos theta. Can someone give me the weight? It's 10,000 G, isn't it?
Yeah.
So what's that? 981. Oh, how many zeros? 2 zeros only. Are you sure? No. No, another zero. Newtons. Isn't that right? Yeah. What?
Yeah, 9810.
Okay, fine. I trust you. 98100. L cos theta equals 98100. Now, does anyone know how to combine these two equations so we can get the theta? What do we do? No. Divide. L divided by L? Cancel. Does anyone know sine divided by cos, what that makes? Tan. Tan theta equals 110 over 98.1. I'll just put it all in. 110,000 over 98100. So what do we get for the theta now?
Mm-hmm.
48.3 degrees. Okay, write that down carefully.
Sorry, I don't understand why we said. Yeah.
Okay, you got that? You got that written down?
Yeah.
Yeah? Okay. Now, last one here. I'll do this one for you, it's quite hard. A ball rolls inside a sphere of radius 5, forming a circle of radius 4. What's the velocity of the ball? So, what you have here, you have this big sphere of radius 5 meters. And then on the inside of it, like here, you have a ball rolling around the inside. And that makes a radius of 4 meters. Can you all picture this? It's like you have a big dome, and inside, rolling around inside of it is a small ball. Can you visualize that?
Yeah.
Yeah? Aoife, can you? Yes? Yeah? So, my question is, how fast is the ball moving around inside this cage, this dome? Okay? So, what would be good to do is just to kind of zoom in here and look at what's happening right here. So, if I was to zoom in, there's the wall, there's the ball. There are two forces acting on this. What are they? Now, it doesn't seem like we have enough information, does it? Do we know the mass here? No, we only know the big radius and the small radius. Let me actually just draw those in. There's the big radius, 5. And then the small radius here is 4. Okay. Now, what is the forces acting on this small mass? The weight, yeah. Which I'll just call mg. And what else? No.
Normal force on the ground.
Yeah, the reaction force. Like this. Okay? Now, what I'll do is I'll resolve this. This direction and this direction. And this here is theta. And this is or cos theta. And this one here is or sine theta. Now, there's some things we know. We actually know that or sine theta, yeah, should equal mg. Okay, well that's one result. That might be useful. So that equals that. Now, what do we know about or cos theta, though? It's a centripetal force. Very good. So or cos theta should equal ma, which equals m v squared over the radius, which is 4. So you have or cos theta equals a quarter mv squared. Now, remember the trick we had in the last question? We can use the same trick here. And or divided by or? Can. Sine divided by cos? Tan theta. The m's cancel, and you're left with gv squared over 4. M's cancelled. Sorry, that's wrong. That is a lie. G over a quarter v squared. So you get tan theta, yeah, that's it. Tan theta equals 4g over v squared. Now remember, I'm looking for the v. So I get v will equal square root tan theta over 4g. Oh, no, sorry, that's wrong. 4g over tan theta. So I'll just squish it here. V will equal root 4g over tan theta. Do we know 4? Obviously. Do we know g? Obviously. So if we knew tan theta, we would be finished. But we can know tan theta. Yeah, you know here is 4. And this length here? 5. And this length here? 3. And so what is tan theta? 3 over 4. So if I sub that result in here, what's tan theta? We said it's 3 over 4. So I can bring the 4 up to the top, can't I? And then I'll get...
Are we not supposed to get the tan inverse of 3 over 4?
No, we don't have to. We can take a shortcut, not necessary. I just replace the whole tan theta with 3 over 4. I mean, you could get the tan inverse and sub that in for the theta, but you get the exact same answer. And so I'm taking a bit of a shortcut. I don't need to use tan inverse. So what's the v here?
7.23.
This is quite amazing. I didn't know anything except the radii, but I can get the speed here. Okay. Now this is a very hard one. In my opinion, this is the hardest question I could think of for circular motion. So you want to write this down carefully. You take it, write this down, yeah. No panic, because that was the last example, so you can write that down. Okay. Did you write that down? Yeah? Okay, you all got that? Right, once you have that written down, there's about 10 minutes left. You see there's a lot of questions to do for homework. That's because this is a popular exam question. You gotta get started. How many homework questions are there?
17.
Nice. Nice.
17.
That's what they say. But we only did one lesson today, not two. So. Close this. You have this? I close it?
Last one.
We've got 10 minutes to do some questions now.